Okay, my outstanding friends, wait till you see this. I have been waiting for this day for over 50 years. And what is it? Atoms decoded at last. They figured out what an atom is made of. The revolutionary quark gluon model, October 19th, 2024. Finally, the scientists have figured it out. Well, let me show you something about quarks and gluons and the transfer of energy from 1968. I had all this figured out. It was a dipole electron flood theory. Everything was made of dipoles. And because I figured that out, they tried to destroy me and literally drove me out of science. I went out on my own, started my own business and all that. It was a ridiculous place to be, to try to work with people that are so indoctrinated that the only thing that matters to them is that somebody told you to say something and you can repeat it. That is academia. All right, now what does this say? This is ChatGPT. Roger Spur, known for his work with Mudfossil University, began his discussing the dipole electron flood theory around 2020. That's 5 years ago. On his YouTube channel, he introduced this theory as an alternative explanation for atomic and subatomic structures, proposing that atoms are composed of dipole electrons. Those are what they call gluons. Rather than traditional understanding of protons, neutrons, electrons, his presentations often include experiments, observations that challenge mainstream physics, emphasizing the role of electrons forming all matter. However, exact announcements and details of the theory are typically spread across various videos and uploads, rather than a single formal publication. Well, I have done a little bit of both, but here is dipole electron flood theory. This is light. That's a photon, and it's made of two dipoles. Each one of these dipoles would be considered an electron. Two of them together make a photon, and they have a field surrounding them. They go through the air this way, and they are concussing with all the particles in front of them, making a glow. And the leading part glows much more than the trailing part because it's hiding behind the black part. As this flows forward in a broader picture, it's inside here. And this is pulsed laser. So it's pop, 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 but the particle is right there. And it has a field surrounding it. All right, so it's just like a big rubber ball. Boom. And all of these are particles that are in the air of oxygen, hydrogen, whatever they are. Dust, it doesn't matter. Everything that is in there that is a molecule or an atom has a field surrounding it as well. These push those fields out of the way. Anytime you have field to field, you have a glow. That is energy. All right? Energy is not what Einstein came up with. And light does not travel at the same speed. You can go faster, you can go slower, you have all kinds of different speeds. And this is the proof of the pudding. Is that these light particles, as I will show you, we have red, green, blue, and we can see it accelerate, slow down. All this was, I really started pushing this in 2020 because I was already 5 years or more denied even to look at it from Fermilab and all the rest of them. And I did go to University of Geneva, which is, they work with CERN. And I told them all about my stuff. And I showed them my stuff. This was back by 2015. And I showed them we were using, we could see the photons. Oh, no, that's impossible, that's crazy. Same thing with Don Lincoln at Fermilab. And he shut me off, told me I was a tinfoil hat guy and an embarrassment to science. This is exact same particles, and he's got me locked down. I can't speak in this realm. You know, he's got me, blocked from everywhere, and insulted me. On top of that, and he has spent billions of our dollars and not paid any attention to what they should have. Now, not only that, let's go back to what they're claiming they discovered. Okay, even if you're not a geek, you'll be able to understand this. It's very simple. But they make it very confusing sounding. They're talking about Parton distribution functions. What the hell does that mean? What it means is the Parton name was proposed by Feynman, Richard Feynman, in 1969. That's when I started in this stuff. All of my stuff goes back to 68, 69, 70, and then they destroyed me in college. And it describes any particle constituent, which means inside a proton, neutron, and other hadrons. They throw names like unbelievable. The particles are referred to today as quarks and gluons. Well, let me tell you something. I knew this back in 68 and 70. Intermolecular forces. There's only two types. And they're dipole-dipole interactions. There's polar and non-polar dipoles. Polar means that they have like magnetic properties almost. Just think of it that way. Non-polar means they're just sort of homogeneous. There's no real polarity to it, no center. There's no dipole. Dipole means the center of positive or negative influence. And this was my paper. Well, my paper was here about all of these interactions. And I mean, I had this stuff done. I mean, I had it down, 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 and they put me down, 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 and I got the hell out, out, out. And this should have been solved 50 years ago. Now, remember that name, Feynman. Now, let me show you something else. I also, well, I told you about the two types of, that's all there is. And the other thing is, the transfer of all energy, and I mean everything, the transfer of energy is from light to atomic vapor. That's where energy comes from. From light is atomic vapor. What does that mean? It means they're little tiny pieces of atoms. All right, and 1,839 of those little bitty dipoles make up one proton. That's all there is, and that is dipole electron flood theory right there. And that's what an atom looks like. That's the anatomy of a proton. Well, protons, this is like the core of a hydrogen. Let's work with hydrogen. It's not one big, huge positive and a negative that's so small they don't even bother with it. It's the same number of dark particles and white particles, which are the gluons. There they are right there. There's a white and a dark. That's all that exists. All right, and when you put them together, they make up gluons. This goes back years and years and years for me. This isn't something brand new. And you take two gluons together like two bar magnets back to back, and they are a photon. That's it. All the rest of the stuff is just fluff. Now, I went on my own, but I did everything that anybody else did. There was nobody that could stand above me and say, "Oh, Roger, you don't know because you didn't do this." I did everything. I did all the different spectrum. I did heat analysis. I did thermodynamics. I did friction, and I mean, there was nothing I didn't do. Chemistry, all the different chemistry. All right, chemical bonding, all the different concepts, energy levels, thermochemistry, all different forces and bonding, and I mean everything, the whole 9 yards. Energies of bonding and non-bonding cases, all chemical forces, electrostatics. So if somebody says, "I didn't do my homework," well, let's see their homework. All right, show me what you did. Show me something that you actually did. This is stuff I actually did. And the things I show are things that I actually show because they're actual physical material evidence. They're not just guesses. Okay, my friends, get ready for this. This is gonna be fabulous. I've been waiting a very, very long time for this. And I see this with a little bit of ambivalence, which basically means there's some good here and some bad here. I'm pissed off because it took 50 years. And I will show you, I had all this evidence 50 years ago. And they're saying, "Wow, Adam's finally decoded at last the revolutionary quark-gluon model." Well, I understand what they're talking about because that was my model 50 years ago. It's called dipole electron flood theory, quark. gluon. There is no such thing as quarks. There is only gluons, and they build protons. And a gluon, as I will show you in my theory, which is right here, dipole electron flood theory, is a black and a white particle. And these are the literal pictures of them. That black and white particle is a gluon. This is the photon. Half of that is the gluon, which was, to us would be an electron. All right? And these are the things that go through your heaters and through and so forth. They have the energy. Photons bounce off things because they have a complete field surrounding them, big magnetic field. And that's it right here. This is from our very early work. And now we have them, so look at this. This was all done with CMOS. Now this is Fermilab, and this is actually literally right from Fermilab's page. These are the particles they were looking for. We found them. I contacted Don Lincoln about this, and I was scolded. I mean, literally assaulted. Now, these are the particles that they've been looking for, and there they are. And this is dipole electron flood theory. It goes back to 1968, 70, somewhere around there, when Feynman was making all of his declarations. Now listen, I want to show you what they say at Harvard about Feynman and about quantum. So don't forget, I've been talking about this since about 2014. I contacted Don Lincoln at Fermilab. I said, I found your particles, here's the evidence. And he said, oh, you can't see that with CMOS, you can't do any of that stuff. And I said, yes, we can, and let me give you the evidence. And I tried to show it to him, and he literally assaulted me. And I am blocked from all of them being able to talk to literally anybody anymore. So I went to University of Geneva for particle physics. And I explained to them that we could see these particles. And they said the same thing, it's impossible, you destroy the CMOS, blah, blah, blah. I said, no, you destroy it because you're using protons and smashing big, huge particles. We're using dipoles. We're using little photons, and they're made to pick up photons. Photons is exactly what CMOS is designed to absorb, is a photon, but not a chunk like this. They're getting hit with chunks like this. And as a matter of fact, when they work around these CERN places, they got to wear badges because they're getting hit with things like this all the time. That's what hurts you. You get hit with sunlight, it's not too bad. And that's all this is, we're using sunlight basically. So we're using the tiniest particles. They're using huge things like this. I'm going to show you all this, but this is from 2020. I really started to push it on my channel. I said, this is crazy. We're spending billions, literally billions of dollars. And I was fighting with Don Lincoln at least 5 years at this point. And again, just assaulted. Literally called me a tinfoil hat guy and an embarrassment to science. And would not, and he said, outright said, I will not take a look at anything you present to me. That's just a fact. All right, don't forget now, I worked with University of Geneva. I told them all this stuff, and we went back and forth a number of times about the CMOS, and I finally convinced them that we were working with the particles that would not destroy the CMOS, and you could see everything. So what happened? CERN upgraded to using CMOS in some of its experiments, particularly in their particle detection, yes, and imaging systems. Now, the reason that they never used it before was, like I said, big chunks would come off of their protons and neutrons and everything, big chunks like this, and it would hit the CMOS and destroy it, yes. So what they had to do was harden it. Now, I don't know what they did. They must have put in some kind of layering of absorption of the big particles somehow and filtered it out, which is fine, that's okay. But I alerted them to the CMOS. If anybody wants to argue that point, let's argue it. Because I also did it with Don Lincoln. I said, yes, we can see these particles. We're using CMOS. They said, oh, no, that's just refraction, that's this and that. I said, no, it's not, it's your particles. We started with light. We accelerated the light. That's light accelerating. All right, before that, it was just sort of a wave going through the air. It accelerates because of the Venturi. And at the Venturi, we did what nobody else has ever done. We created fission and fusion. And they're trying to measure how fast the entanglement comes back together, I can measure it right there. It's right here. That's the Venturi. And well, separation point is about here. This is how long they stay separated. Prior to this, they were entangled. This is what they're looking for. All this, we got everything right here, everything. We created sterile muons, the black one. You see that? That's a sterile, all these are sterile muons. And the sterile muons come back to their white counterparts right here. Here they're separated. This is what they should be. They never should be apart, ever, 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 ever. These two come apart unless you have a nuclear, a subatomic nuclear explosion, which is what we created. Subatomic nuclear explosion. These particles make up the nucleus of everything. They're these little bitty particles. So this is the nuclear bits, and this is a nuclear bit right there. And we exploded that and created fission, where they broke apart, and fusion, where they came back together. And we can literally measure where they broke and where they came back together. That's what they're trying to do right now. We did this 10 years ago. And refusal from every single particle physics place, other than just, when I ended up with University of Geneva, I said, can we do something? Can we set up some experiments or something? You know what they did? They sent me a thing saying, no, we'll follow you on Facebook. I'm not kidding you. That was the response. And that was, and it was done. Now, to do this is very inexpensive, and it's very, I think it's effective, and this is what they want, is that white shower, because the white shower has no mass and it has all the energy, and if we can filter that in right there and absorb that. Hold on a second. All right, just pay attention to this. This is the light. It's not supposed to accelerate, but it is accelerating extremely fast, and when it hit the Venturi, the black separated, and the white is the only thing that streams through there, and it reattaches to the black here. We need to put a harvester right in there. All right, so here it comes, the laser, black and white. Bam, the black stays here, it can't go. And it slaps the white through. It really squirts it. It just squirt, 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 squirt. That's what it's doing. It's just like you're, like a bug squirter, you know, that type of thing. A sprayer. And it's spraying out the white particles because they're the only ones that can get through that Venturi, and they have no weight whatsoever. You put those in your car or in a battery of any sort, and it will not increase the weight of the battery. However, the battery becomes extremely charged. If you took a car and you could drive 500 miles with a fully charged set of batteries, the car weighs 4,000 pounds. It's fully charged. 100% of the energy is in the batteries. You drive around, you use up all 500 miles, you come back and the car goes, you can't go anymore. How much does it weigh? Same way as it started, 4,000 pounds. What happened to that energy? Well, it stayed within the system, basically, and it doesn't have any weight. So you fill it back up with energy, what happens? It still weighs 4,000 pounds. There's no change because the white has no mass. And I show this in the atomic bomb blast when the black separates from the white. And we actually showed it in the experiments where right there is the black separating from the white. The black stays this side and it readjoins here. But in the interim, we should be able to suck that white right off, because that's all you're doing. When you have a generator, it's pushing, 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 pushing electrons. Just a white. But it takes a hell of a lot of energy to do that. Well, here, by using this Venturi, we use no extra energy whatsoever. None, zero. It just forces the fields, instead of hitting head on, they crush sideways, but there's nowhere else to go. And at that point, the black backs off. It's too big. The black is a fixed particle, exactly as Don Lincoln says in his, right here, this is the extended fixed particle, and that's the white glowy one. All right, exactly what he says. In summary, the extended black particle has a fixed size, never changes. You can't fit it through that Venturi. They have a fuzzy edge around them, absolutely. The point-like particles, the white ones, are mathematically zero size. There's no weight to them. That's why they run a car of this from this stuff. That has the weight. That has all the weight, but they're normally glued together. So light has weight. Light does have weight. There's no question about that. And it can push things. Even a Crookes radiometer, which I have here, and I can show you. And the beauty of the Crookes, I can show you something that nobody even has any clue about, is you can push it with the light, but you can also suck it back with the light too. How do you do that? If you can push it with the light and suck it back with the light, well, you push it with the light on the black side and it sucks it back on the white side. Why would that happen? It actually sucks it, makes it come backwards. All of this stuff is solved, these mysterious things, by dipole electron flood theory, which is what's correct. This is what's correct. And it changes some things. It changes some chemistry. It changes, redshift is ridiculous. Space and time is crazy. Everything that's done in space and all of this, we know how far these galaxies are and all that, it's all based on the speed of light being the same speed. It's not. It's not even, that's just insanity. And I can show you it's not true. There's light accelerating. That's not supposed to happen. No law in science can account for that. None. Zero. Zero. It does not allow for this. What else doesn't it allow for? Light slowing down. Well, does light slow down? I'd say it does. It's coming in fast here. It's spinning. And spinning to the right, which means the particle is drifting to the left. This is all one shot of light at one time using CMOS, which CERN upgraded to use after I told them that we were using them and we were getting these pictures. And this is a picture of a photon. That's the photon right there. Why is that little glowy stuff going on there in front? What's all that about? That particle is moving this way. They call it upspin and downspin. This would be downspin. When they can see it, it's glowing. When it fills up with it'll go this way. It fills up with energy. It's just the field gets too big, and that one will come back, and then it'll start to glow. And that's what we could see on here. You see, when you look at this, you don't really see it all that well. You see here? You don't really detect what's going on until you see it in a different way. Like this is actually this in energy levels, and this is this. So we're getting much more energy down here, and what's happening is we're banging in all of this stuff. You see how this is red glowing here? That's starting to get energetic because it's pushing through, and these particles too, and they're being pushed up here. This is, whenever you see energy, the white, it's energy. It's energy. It's pushing and shoving creates energy. And this is where the particles are pushing through. This is a big field around it. As a matter of fact, I have all this stuff in very nice detail now. Here's a particle going through the air. All right. Inside this is the dipole, the two gluons back to back, photon. And it's got a field, and it's just fluffy, and it pushes, and everybody else got to get out of the way, so they give off some energy. It's pushing and shoving. All right, so that's it, just starting to accelerate. Here's where it really starts rocking. All right, you see that? The particles here, and now it's starting to accelerate because of Venturi. That's the nature of Venturi. It makes things accelerate. It's fully understood. It's exactly like putting a nozzle on the end of a hose. If you took the nozzle off, it just goes blah, 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 a lot at one time, just dribbling out. You put the nozzle on, you get a little at one time, but it just squirts like hell, and that's it right there. And right there is fission, The black comes away from the white, and there is fusion, and we can measure that distance right there. You see these? You wouldn't know these fields were here. Those are more particles, but you would never even see them because they don't impact hard enough. The only reason you're seeing them is because they're being banged back from the explosion. And this is literally, and I am not kidding you, this is a subatomic nuclear explosion. And this right over here, my friends, is what's called reverse EMF. You see those backwards looking curved fields? That is explosion on steroids coming all the way back from the point of impact, the nuclear explosion right here. That's a nuclear explosion. There's no other way to put it. When you have a nuclear explosion, you're breaking the nucleus apart. These are parts of the nucleus. This is a subatomic nuclear explosion. When they have a nuclear explosion, they have big ones like this, and they bang and they throw off huge particles. Well, we have a subatomic because we started down in this range. We don't have to worry about any of this stuff. And here's the problem. When they look at that from CERN and so forth, they're just looking at debris. It's just nothing but debris. Look at this. Here's what they do. Bam! And what happens? It's really these. A proton is 1839. All right, it means it's charged. A neutron is 1840 of these. All right, which means it's neutral. It doesn't want one, it doesn't want to give one up, it doesn't want to take one on. The proton either wants to join with somebody and give one up, or it wants to take one on, but it wants to become neutral, basically, or stable. So they go boom, and what happens? These go flying everywhere. And then they dig through them for literally 10 years with like hundreds of people looking for these little particles, and they find the same ones we found. And they find little tiny photon-looking things. They find little bits and pieces of the green, red, and blue particles. Some of them are more energetic and less energetic. That's why they're different sizes. And they just don't understand what they're looking at. All right, so when we break our particles apart, we get this. This is where they start with. And when they hit over here, boom, they explode into little bits and pieces. But you can see them growing in energy and then exploding at the Venturi when they become, whenever you see photons, they are in their extreme energetic phase, basically bouncing back from something like hitting a wall. And they think they hit a wall because of the reverse. Remember I showed you those reverse waves? And then you could see, well, let's just go back to them so that I don't confuse you. All right, you see these here? Those are because of pushback of this field. Field to field causes a glow, and of every different color, and because there's just a different spin rate. And that I can prove as well. Here's the green. And here's the red. You see the red is dull, the green is much more brilliant, and it just pushes the red out of the way. And it shows up here. Well, the green is much faster, much more energetic than the red. And the blue is off the charts. You can't really work with the blue. Through glass, you can see the blue coming through here. And as it's coming through hot, and as it pulses and bang, boom, bang, boom, 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 boom. And that happens through our universe as well. Everything that they're doing now in astrophysics is based on speed of light. It's constant, and it's just not correct, not by any possibility whatsoever. Okay, my friends, all of astrophysics is based on the theory of relativity, which is that the speed of light is constant in a vacuum. Well, that's not true, and the space is not a vacuum. You can speed it up and slow it down, and a vacuum means nothing because there is no vacuum anywhere. And even my friend Don Lincoln says empty space isn't empty. It's not empty. It's full of subatomic particles. He's right there. Some of the subatomic particles are real and have a measurable impact on our universe. Right? That's one thing that Don said was right. And he could see the other particles. They could see them after 10 years with hundreds of guys poring over. They found these were the 2 smallest particles they could find. All right. And then he goes on to quarks, leptons, bosons, standard model, point-like particles. Well, these are the 2 smallest particles there are, and we did find them, and they are in light. And there they are. There's Don's particles. There they are. And they're part of light. And all light adds together to make up protons. So every proton is just nothing more than a ball of electrons. That's dipole electron flood theory. And the electron flood theory itself shows that the proton is constructed like this, not a big solid dark core, but it does have a solid black core, but every one of those is an individual particle. And in my model, they lock on to electrons which flood around. That's what I call electron flood theory. They're dipoles and they lock in. Now, the best ones, the tightest ones, are down closest. They're really, really tight. Those are the blue ones. To rip those away, you really got to do some pulling. And then the next ones are the green, and they're pretty hard to pull away too. The red, they sort of float around. And Fermilab agrees with that. They all agree with this. What I'm saying is the red ones don't go too far. All right, somewhere around here to show it. Hold on, let me show you what Fermilab shows. You want to see something funny? These are Higgs fields. The white is now coming in and smashing back into the black. I can show this in a separate, different way. This is our Higgs fields, the actual Higgs fields coming from the light experiment. This is CERN, or actually Fermilab, but they basically the same thing. They're hitting these gigantic things head on, and boom, everything just goes flying. Well, you see these ones that the blue, they don't come back. The blue take off and go because they're the tightest ones. The yellow and the green and the other ones, these white little flickers going on here, they leave basically and don't come back. You start to get to the reds, and the reds are sort of, they fumble around because they're just not held so tightly to escape. They don't really escape in every case. In some cases they do, but mostly they don't, and they just sort of hang around, and that is what my model would predict as well. All right, because the blue ones, when they go, they got to really be ripped and they're not going to come back. The green, they're going to go and not come back. The red, they're going to get bounced and float around, basically. Some of them will go. All right, so I have no dispute with that. The dispute I have is that this is the only 2 particles that do exist. They're not part of hadrons or any of that stuff. Those are just names made up for chunks of these 2 particles, which are the only 2 particles that exist. And they call them Dirac neutrinos. They're consisting of a black and white particle attached. Gluons seem to be electricity and heat, which flows when pushed by the white electron fields or pulled by the dark matter. This is dark matter. It's part of light. It's just dark matter. We never knew it was there. And an electron is not just an electron. It has, well, it is and it isn't. It's, the electrons are attached to muons, right? And they normally appear to have almost no mass at all, and I mean none, as far as I can determine. They have an extreme attraction to the muons and are heat and light and create electricity in conductive materials. In other materials, they just burn things up. They just burn. I guess I got to show you the atomic bomb blast. But anyway, muons are the tiniest fixed particle. They are dark matter and dark energy, and it's also cold and gravity. This is cold. All right, it balances the heat of the electron. All right, muons have mass, and there are approximately 1839 or so in each proton. Muons form black holes in all matter and can grow quite large in outer space. They are the source of the black holes. And I reported this to Don Lincoln back in 2015, I believe it was. The Russians made this. I copied him on correspondence to the Russians about this black hole being surrounded by charged particles. They flipped out. They said during the experiment we contacted the Earth guys. They couldn't believe it either. They freaked out. And this is all this charged particles. And Don was less than gracious. So that went nowhere. And also, listen to this. The Russians also found this. When they did it in cryogenic, which is a cold, those charged particles took on what looks to me like DNA-ish. And it even has this little bars going across. I mean, that looks like DNA to me. I don't know what you think. And that was out in their space station, you know. And like I said, that was 10 years ago. This goes back a very long time. That's why I'm so frustrated that, you know, all this was put in Fermilab's hand. And as far as I'm concerned, they just let us down. You know, and the only one he'd get through to was Don Lincoln. And I got through to him, and we went back and forth, and he finally blocked me, and he just said, I will never listen to a word you have to say. You're a disgrace to science and an embarrassment and all kinds of things. And I can't believe he doesn't understand what's going on here. It's just impossible for me to think that anybody could be in this business and not have the competence to understand what they see. Especially when the detail is so elegantly. It is what it is. And light spins. You see this? Remember I told you it goes bzzz. Well, I can show you that it spins in the pattern that it makes. It's all over. They're all over here. So it spins. Sometimes it goes this way, sometimes it goes that way. But it's always spinning in this direction. This is nothing more than a drill bit. You go to a machinist and you say, what do you see here? And he says, I see the tip of a drill drilling through something. Well, what it was drilling through was a Venturi. And here's what it is. This was the experiment. The Venturi's coming through. The light is coming down here. Boom, 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 pulsed. And it hits this. Now, this is the pattern that it displays back here. Is that. All right, so all you're doing is running it through a Venturi. The Venturi is not the double slit experiment was what Rod Warren was trying to do. Instead of using flat plate, he used 2 round nails, well 3 actually in the beginning. And he shined a laser through there thinking he would see the waveforms, and he saw this, and he also saw all these other patterns that I'm showing you, like this right here, coming out of there. Now, he spent literally, must have been thousands of hours. I worked with Rod for, it had to be minimum 5 years. And this is the white particles here coming out and hitting right there. This right here is this right here. And this right here is this right here. All right, and before that, on the other side of the Venturi, the black ones stacked up, which means they are the sterile neutrinos at that point. All right, so here's what you got. The black ones stacked up right here. They can't get through. It's nothing but white. And now they come right back here. So I see we should be able to measure that distance, how long it takes for them to come back together. Now I know the green won't come back at the same. Green will come back way out here. And I can prove this. I show you those 2 at the same time going through the same Venturi. All right, so here we are. This is the photon. Now that's a red one. All right, but green is this exact same thing, only to be green all around here as well. These, you see how you got red, you got blue, you got green, different colors inside there. Those are different energy levels of the different distances from the core of whatever is creating this field. And I just don't know. For some reason, there's a field being created here. It's like a bubble of just energy that has no mass. And I know it has no mass because of the atomic bomb blast. You know, I will show you that. I'll have to show you so you understand. These can be separated, and when these hit, they just burn. They don't even push the house. And then these come behind and knock the house over. I'll show you in a minute. But these are the particles. It's just, that's what they are. Those are photons. Now, I said I can show you them both at the same time. Here they are coming through the Venturi at the same time. You see how brilliant the green is and how dull the red is? The green comes back way out here. Now, here, it's so powerful, it forces these to tumble. So I know the green's going faster than the red. If they were both going the same speed, it wouldn't force these to spin like this. They never, ever, 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 ever spin in this direction. That's just not the nature. They spin this way. I don't care if they're going this way, or going straight up and down. If they're going this way, they still spin like this. And I can prove that as well. Everything I say, I can prove. I'm not making any guesses whatsoever. Here's the green. You see how that's straight up and down? It's going this way. But it's still traveling this way, spinning a polarity towards the Earth. This is just getting ready to flip, because the leading green is charging, and it will go like that, and the back one will come in front and start to, that's the muon wobble, they call it. And here it is in its neutrino phase prior to becoming a full-fledged photon. Now, this is that green light coming through the Venturi. Now, the green is harder to control. This side has no black whatsoever. You see it? None, zero, no black. All the black is being diverted this side. Now, that brings up a whole nother possibility of the Venturi, that if it was angled in a certain way, you could drive off all the black. Because you don't want any black to come in with this. If you're going to harvest this for energy, that's all you want is the white. It has no mass. Let me just show you to prove that. All right, so don't forget, this is just crazy. Astrophysics, all of it is based on the postulate speed of light is constant in a vacuum. Well, space is not a vacuum in the first place, and it's not constant because you can speed it up, slow it down. There's just not a thing right there. Nothing, zero. And just like they said, Professor Shankar said, nobody understands the quantum mechanics because you can't and live with these rules and restrictions. They just aren't correct. All right, I'm going to show you an atomic bomb going off, which proves my point. The dark matter is in the center. It's the heavy, really stuff that hits you, and X-rays are made out of this stuff, gamma rays, all of the destructive energies way up at the top end, up here. There's a certain point where you lose all the electrons, they're gone. It's going too fast. And all you have left is the gamma rays, which they call ionizing, which means it blows off other electrons. And it's called the ultraviolet catastrophe. So it gets more and more and more and more energy, and all of a sudden you lose everything, and all you got is your dark matter left. Now, what happens in an atomic bomb? It's just nothing more than a gigantic glob of electrons around a gigantic glob of black particles, and the more and 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 more you make, the more enriched it becomes, the more unstable it is. Because everybody's field is fighting everybody else's field. But they all want to get to this black. So the more black you can put in the center, the more white will try to force its way in. Now, and at that point, then they clad the whole thing with explosives and plates and so forth, and they explode it in, and everything goes out. Well, what's going to happen? What's going to go out first? Well, it's going to be these. So you see nothing but brilliant white, but they have no mass. Prove this in a moment. And then what will come next? The black. And what will the black do? It has all the mass. let's watch that actually happen. I'm going to show you in this video. Now, this is when they were doing tests on the nuclear bombs. And this is atomcentral.com. They got a truck here and they got all this stuff. They brought all this equipment out. Now, they're going to take the truck out of here and all that. They've got a literally a video camera watching this direction in an enclosure, a hardened enclosure, so it doesn't get damaged and it's not getting visually whacked by the light. And so they're watching what happens. What happens when you set off an atomic bomb? Now, I got it playing very, very slow. It's in slow motion. What you're going to see is the poles, the wires that run between the poles, the roof, everything here will just burn. And nothing will move. Not a single thing will move. It'll just smoke like this. No push. And then all of a sudden the black will hit the house and it'll be the end of it. Now, of course, it's not going to make that burn because it's metal. It will not absorb any electrons. All right, anything that can absorb anything, even like the poles, the wiring, everything. But if there's a metal object there, it will not absorb. It's not going to combust. All right, so here we go. You ready? Here goes. I got the sound shut off. And all of a sudden, they're going to go dark. Now, watch the first thing that happens. Boom, I just stopped it. It's just nothing but glow. What the hell is going on? It looks like smoke. It's not smoke, it's electrons. Every electron that's coming forward, as I showed you, will create glow when it hits another electron. And these are just nothing but the glow. So there's no black coming yet. Now watch, I'm going to just go forward here kind of slowly. Look at what's happening to the house. I'm going to stop it again. The house is just nothing, just nothing. Look at the poles, the wiring, the poles. They're just smoking up. What's happening is the particles here that make up all these combusted materials are, the electrons are in there and creating such an expansion inside of the electrons. They're not pushing them anywhere. They're just causing the electrons to expand. And then they just smoke off as they combust, as they deteriorate the molecules, basically. So let's just go forward. Just smoking, just smoking. Now you see the metal, that doesn't burn, and the side here, we're hitting this way. The camera's over here watching. And so this is not being impacted directly with the light, so it's not burning. That's not burning because it's metal. All of these things, anything that will absorb electrons is burning. These are not burning because they're metal. Now watch. All of this is just vaporizing. Now comes the black. Watch. Boom, there goes the black. If you can't understand, that was two separate events. And the only possible way that that would happen is exactly what I show in the dipole electron flow theory. Two separate events. All right, the white hits first, and here we have it right here in the experiments. The white is hitting a house right here. The house is just burning. And then the black comes behind it and takes the house. And what's all this rippling out in front? Those are called Whistler waves. And I did a video showing that in another experiment, they're way off watching, and you see the mushroom cloud go boom, and you hear, and that's what this is, instantaneously, from way, 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 way away, which takes this wave, comes across the desert, and you see the desert just sort of doing this, doing this, doing this, doing this, and then boom, everything hits. But it took probably close to a minute by the time the thing hit. But as soon as instantly the bomb went off, you could see the little glow, and you hear, and that's it's an audible, called Whistler wave, and that's it. You see how big these are? You see how tight these are? That's just a bump of electrons. A whole different situation. You know, this is all new physics, all brand new physics. Nobody has any idea about this. But I'm going to tell you right now, if they say that this is empty space and this is a vacuum, that is absolute total insanity. Everything they're doing, Hubble, Webb, oh, we could just go right through that, no problem. It's a vacuum. It's not a vacuum. There's nobody in the world can say that. And look at this. This is just another thing done with a cell phone. These are fields in space. They're still looking for these. They can't find these. I'm not kidding you. You see the little doodles they have about their quantum, you know, they call these gravitational waves. Yes, they are. These are magnetic fields that surround different things in space. And everything in space is a dipole. And there's some of them are just crazy looking stuff. And they have fields all over them, and the fields interact with each other's fields. That's our moon. And this, again, I don't want to use people's names because I think a lot of people want to stay out of this. They've been assaulted for, you know, getting involved with me, basically. But this is not, you know, what we've been taught is crazy. Look at this. I think this is the Pleiades. And this one here got my mind streaming. Now, I say everything's dipole, and it is. Look at this. This is the black behind the dot. This is the white behind the dot. And this is the dot, and it looks like the dipoles here, and the dipoles are here, dipoles are here, and this one here is just really like dipole blackness supreme. And this is dipole whiteness supreme. I don't know. And I believe this is the moon. And these are all the fields conjoining the whole thing. And this was taken at night from New Zealand. And it was just with a cell phone. This is about maybe 3-4 years ago. A nice guy. I'm just going to mention his name. If he wants to be involved, I'd love to see that. But most of these people send me something and they don't want to, you know, I don't know if I should use their names or not because they don't respond back again, so I don't know whether they want me to do that. So as a matter of fact, I'm just not going to use anybody's name unless they want it. And he knows who he is. And I'd love to see some more from him because I got this and I got a couple other ones from him. This was one and another one. I mean, look at that. And he said it was just with a new cell phone. He'd just gotten like, I don't know, 3-4 years ago, something like that. But look at all these. Anytime you see a glow, there's energy. There's energy there. This is on top of the moon somewhere. I don't know what's going on there. But these are fields that particles have to pass through. They're going to slow down, no question whatsoever. Everything that we're doing, we're just wasting our money looking off into space saying, oh, that's 4 billion zillion years ago. And it's, well, Einstein's right. You can't accelerate light. You can't slow light down. Well, Einstein was not right. And nobody's been right. And Feynman was, he said it. Feynman was the biggest guy there was in physics. And he goes back to my time. He said, nobody's ever, there's no way to understand this. It can't be understood. And he was right. All the way up to where you just saw Professor Shankar. Nobody understands it. Just say what I say, and people will think you're a genius. I go for material evidence. Here it is right here. There's no question what I'm showing you is factually, can't be disputed. And here's the things they show, is little doodles like this showing the two particles. And they're not like that, they are like this. They're always up and down. But they are neutrinos just like that. In 1839 make a proton, 1840 make a neutron. And all it is the periodic chart just keeps getting bigger and bigger and bigger and bigger and bigger. And hydrogen is not one big proton and one tiny, tiny electron. It's 1,800 and, I don't know, 40, 45, something like that, dipoles. And helium is up over 7,000. By the time you get up into these, the particles are so giant, there are hundreds of thousands of particles in here. They just go one proton at a time, but every proton which appears to be stable. I agree with that. They have periodic stability. And a proton, like I say, I think is about 1839, something like that. And they get stable in those masses. But they say 1, I say 1839. So when you get up to hundreds of different particles of theirs, it's hundreds times 1839. So it gets up pretty big. Now, if you're going to have anybody that's going to be involved in physics or wants to get into physics, they're going to have to understand what we've been told about space and about the vacuums and so forth. It's not true. It's just totally wrong. And there's a black hole inside there, and it's accumulating all the white particles around it, exactly like the Russians showed in space. Because once you have charged particles, they will they'll push the black into a center. It appears there's more black than there is white. Or I don't know, there could be exactly the same number, I have no idea. But all I know is when this came through the Venturi, let's look at the Venturi closely. Where's a good shot? Well, this is pretty good. Well, wait a minute, let me get a better shot. All right, let's just get a couple of ground rules going on. This right here, there's pins here, similar to like round discs like this, only they're straight out. They're pins. And they're tuned to a point where only the white can get through here and the black cannot. You see how the black is standing off here? And here's exactly the same representation. They come in as photons, back to back, black and white, 2 gluons. And here they just disassemble. And the black keeps banging, 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 and squirting this through. Now, they reattach right here. You see this? There's almost its exact straight line here. They'll reattach if they can get to them, right on the edges. You see the black ones jumping in? But it appears that there's a certain distance straight across, straight out, where they do attach. Now, I know the green ones don't until they get much further out. So there's a much more distance on the green, and then I'm sure there's a bigger distance on the blue. So this is, this white will be an energy level equivalent to its frequency. All right, now if that makes sense to you. So, in other words, we have red here. All right. Red is down in the range where it's sort of long distance. So the energy is not going to be powerful as it will be for green, which is going to be a nice tighter. So here's what it looks like. This would be red. Let's say red is way out here. All right. So when it comes through, it's bang, 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 bang. So that's how much it's doing. Now your green would be down here. So when it comes through, it goes bang, 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 bang. So you're really getting some power of that white. When the blue comes through, it goes brrr. So it's on steroids with the blue. The blue is just before it loses all of its electrons. It's so powerful. And then you get into the gamma rays after the ultraviolet catastrophe, where there's no more energy left. Drops right down. They expect it to just keep going up and up and up with energy, but it hits a certain point and it zip right down to zero. If you're a geek, you should get into this stuff because it's very, very interesting. And this is exactly what they wanted to see, was the muon going sterile, the muon neutrino going into a sterile muon, and they wanted to see the electron and neutrino going into showers, which electron shower, there it is. It's exactly, which also means that when these things separated, that's fission. They were normally associated together. I showed you that, it's very, very clear. And they will always be associated together. They will never be separated unless you did what CERN does or what we did, or it's coming off the sun or some extremely high energy source. This is extremely high energy, even though it's very compact. And you may be able to actually get free energy out of this. This is what I was hoping for. Is this right here. All right. right? We just carried something like that around. You could plug anything you want into it, just set your little devices inside, have thousands of these little lasers. These are so tiny, you could have thousands of them inside this box, and photo receivers running into a good bus, which means a big heavy-duty photodiode assembly coming down and loaded into the battery, just exactly what you do now. This is the source of electrons. This is just nothing more than like a solar panel here that it collects them and sends them down. Only we got just raw electrons. When you pick up electrons on a solar panel, you're getting both the black and the white together, and you're hoping, well, it will separate depending upon the materials that it hits. But it's still, they're expensive to make, first of all. They're certainly nothing like this, nothing you carry around with you. And this just happens inside. The laser makes more energy than you're putting in. That's, I believe, almost for certain. So you just tap a little off here, and if you got 5 watts running this laser, you're getting 1,000 watts over here. And I think that's about right. You should be able to get at least 200 times more than you're putting in, if this is correct. Because this is what they're looking for right now, is the high luminosity. At CERN, luminosity is energy. Now, I think I showed you all my papers and so forth, but when I was in the Army, I had a very high GT score. GT means general technical. That means you can do actual things. It's not just knowing something, you know. Okay, this is when I just got out of the Army, 1970. And I did very well in the Army. I was a Spec 5. I went in as an E1, and I went to E5 in 7 months. And they hated me for that. But I did it because I had an extremely high GT score. General technical means that you're able to do things in a technical manner. You know, the things that I do. I go deep to the source. I go to the molecules and the atoms and the gears and the pulleys and the cranks and all that stuff. I got to know how things work. I got to get to the bottom. So that's basically my technical ability. Now, what does that mean, 139? Well, here's what it says. Army General Technical, the GT, has a long history, runs with parallel with research, and means for attempting the assessment of intelligence or other abilities, which is all your abilities, your intelligence, your ability to work with your hands, understand how things work. A composite score derived from elements of this is called General Technical, abbreviated GT, which is up above 139. If you scored 136 or higher prior to 1980, Mensa, which is the real, you know, academics, will accept the result as proof of being in the 98th percentile. I was 139. My GT was 139. Whoops. All right, so they put me into a nuclear missile site servicing the nuclear missiles. And here's it. This is it. Show right here. It's at the 524th Ordnance Company, 43rd Artillery Division up in Alaska. Userol. That was the patch we had on us. I used to call it the Teddy Bear Brigade. You know, this is the land of the midnight sun. And there's some other stories I could tell you about this that blow your mind. Absolutely blow your mind. But I went in as an E1. I went up to a Spec 5, and I went to a Spec 5 in September. I went in February. And by September, I was at E5. And a lot of these guys that were in when I went in, they just made like E5, E6. They've been in 10, 12, 14 years. They were not happy. 7 months I'm in, and I'm an E5. And they you know, it was a tough spot to be in. I had to fight, and I really did. I actually had to fight. I had to go against my sergeant, and I ended up winning because I said, I'm not going to stay here with you. He told me, he said, I'm going to harass you till the day you leave. I said, I'm out of here. See you later. And I just walked out. And but I was the only one trained. I had all this training. And so he came running over and he says, you can't take him out of here. He says, well, you're just treating him nasty. And I said, yeah. He said, I'm not going to stay here. And it ended up, he apologized and we got back together, and then I never had another problem. But you know, there's always, when somebody gets in control of something and they feel like they're up above you, and then for some reason, like I'm doing right now, I'm just coming around, I'm saying, here, you guys are wrong about this, you're wrong about that, you're wrong about this. The person's wrong about everything because they won't pay attention to what they're doing. So they hate me for that. I understand, but all you got to do is pay a little bit of attention. We'll talk about it. We'll start to understand reality. If I'm wrong, I'm wrong. But you got to prove me wrong. You can't just turn your backs on it. And that's what's happened straight across the board. And we're paying billions of dollars, especially the family law. I was very upset with this, and I still am, because I'm blocked. I cannot speak to them at anywhere. And I had somebody say, I commented on Don Lincoln's page the other day, and he responded like a kid, which I can fully understand. He's the same with me. He literally he called me a tinfoil hat guy and an embarrassment to science. I said, can't you see the particles? Don't you understand? We use light. You can't do that, you can't do that. And it never turned around. At least CERN did. CERN, they upgraded to use CMOS. Exactly like I mentioned to University of Geneva. And then about a year later or so, they shut down. It took them 3 years. They shut down to upgrade to CMOS. Yeah, they're really trying to jump on board with my theory. They're talking about quark-gluon model. They finally decoded, and as I think I've been talking here, there's no such thing as a quark. There's dipole electrons, and they flood to create stability at approximately 1839 particles together. They lock in as a period on the periodic table, basically. I don't disagree with the particles that they're talking about. I just disagree that they're made up of protons and neutrons instead of dipole electrons. So this solves all the issues with the particles of life and all half-lives and isotopes, all the things they can't explain. They can't explain any of that stuff. And there's no such thing as a quark. A quark is another one of these particle zoo things that just doesn't exist. Now, they say for the first time, quarks and gluons are used to describe properties of atomic nuclei. Well, the gluons, which is my stuff, and I've been talking about it for years and years and years now. See, it hadn't been explained by existence of protons and neutrons. They just don't exist. They exist as masses that are stable. Now, this goes back to the 60s. Listen to this now. This is why I'm upset. Because they're talking about nuclear physics breakthrough. Nearly a century has passed since protons and neutrons, the core components of the nuclei of atoms, were discovered. Initially, they thought these were thought to be indivisible. You had atoms, and that was it. Every one of these you couldn't break apart. You just couldn't break them. Well, they realized that was just totally wrong. In the 60s, now that's where I showed you, I was in 68, I was in the Army, and 70, I really went full blast, and they just destroyed me in academia. So in the 60s, scientists suggested these components might show a more complex structure involving quarks and gluons. No, just gluons. That was my theory, was dipole electrons. Now, when observed at very high energies, they could see these other particles. The hypothesis was soon confirmed through experiments. Surprisingly, despite many years of research, scientists struggled to align the results of low-energy nuclear experiments, and it goes on and on and on and on. Bridging nuclear physics, quarks to nucleons, they come up with all this stuff, and we're going to make this work with that. And they still can't get away from the speed of light. Advancements in high-energy particle physics. This is where, here we go, CERN, laboratory in Geneva. All right, I went to the University of Geneva for particle physics. I explained exactly what we were doing. The main objective is to study these partronic structures. Well, that's the pieces, the parts. They make everything sound so complicated, like it's not complicated at all. Theoretical innovations, well, now we're starting to really think. All right, the results, they're talking about 18 atomic nuclei studied, Parton distributions, and unifying theories in nuclear physics, yes. Dipole electron flood theory. All right. Pairing of certain nucleons, they're starting to come up and working around the edges. It has been possible for the first time to reproduce the behavior of atomic nuclei. Well, I don't know about that. It's all about the particles. Now, listen to this. That one there is the quark-gluon model. They've just finally discovered it. Well, gluon's a long time been doing that. Now, what about this? How fast is quantum entanglement? This is the other thing. They're entangled. You can have, here's what they're saying, which is insanity. These two particles are together. These are the dipoles. All right? These are the quantum particles. And they get disentangled for some reason, whatever reason, but they will always find each other again, the same particles. That is literal insanity. That is just so far off the clock that's unbelievable. Listen now, they say, how fast is quantum entanglement? Scientists clock the speed of the instantaneous. So how long do they stay apart? That's what they're measuring, and I can show you how long they stay apart. It says, an atom is hit by a laser pulse. One electron is ripped out of the atom. Another electron is shifted into a state with higher energy. Well, who says that? Scientists have developed simulations. This is the kind of stuff they show. You saw the kind of stuff I show. Simulations to investigate this stuff. I'm showing a real thing. They go quantum theory and time traveling. They come up with all kinds of crazy stuff. Now, what they want to know is how long do they stay apart? How long will they stay disentangled? It says an attosecond is an extremely small fraction of time, a quintillionth of a billionth second. Now listen to this. Quantum entanglements explained. Let's see what they have to explain. If two particles are quantum entangled, it makes no sense to describe them separately. Yes, it does. That's the matter, and that's the energy. Even if you know the state of this two-particle system perfectly well, you cannot make a clear statement about the state of a single particle. Yes, you can. I can see them. You could say that the particle have no individual properties. Yes, they do. And there they are. They only have common properties. They will always glue together. Yes, I agree with that. From a mathematical point, and plus they are all the same size. The black balls are, every single one of them is exactly, identically the same size. Identical. Whether it's red, blue, green, I don't care what it is. These are just fields, and they have no mass. All right? So you could say that particles have no individual properties. Wrong. They only have common properties. Agreed. They do have common properties, but not only. A mathematical point of view, they belong firmly together. Yes, they're always going to be together, even if they are in two completely different places. No, that's ridiculous. If it's over here and it's over here, they're in two different places. That's it. They're not together. And this is from whoever this guy is, Institute of Theoretical Physics. In experiments with entangled quantum particles, scientists are usually interested in maintaining this quantum entanglement. They want to say, oh yeah, they're entangled, as long as possible. For example, if they want to use quantum entangle for quantum cryptography or quantum computers, we, on the other hand, are interested in something else, in finding out how this entanglement develops in the first place, because they're dipoles. and which physical effects play a role on extremely short time scales. I can show you that right now. They're talking about the quantum birth times and entanglement. They want to measure how long they stay glued together. It says the birth time of the free electrons that flew away was likely later, on the average around 232 attoseconds. So what they wanted to do was measure how long they stayed entangled. Well, we can actually see physically how long they stayed entangled. And here it is right here. They broke apart here, so they were entangled coming here. That's entangled. They're glued together. They come unglued. And right here, to my mind, that line right there is the line. Straight down here. You see it? It's straight away. And they come apart basically right here. And in here is just raw, powerful energy. And if you could harvest it right there, that's all you got is the white, and that's all you want to drive your car, to heat your house, to do work, to pump water, to put out fires. We got fires burning right here. They're dropping with water with the helicopters right around in my area here up in Connecticut. Very, very dry, very dry. And things are changing desperately fast, and it's because of combustion. We're expanding the atmosphere, and the more we expand, the harder we scrub through the universe. The universe is not empty. It's absolutely insane to think it is. So that the more we blow up our environment, the more scrub is going to create more energy, more turmoil, and more rub, and more heat. And that's what's happening right now. There's a hot zone. It's almost 3,000 degrees at the edge of our atmosphere, which is the ionosphere at the top. And then it goes down to -80 because it's a dipole. All right, so you got like over 3,000 degree temperature difference from where the outside is to right below. And then it gets hot again at the surface of the Earth. That's why we're getting warmer and warmer. And then the Earth absorbs that last bit of heat. That's where the waters are heating up, the surface of the Earth is heating up. We're overloaded, and it's because the expansion of the atmosphere is causing that scrub. And the same thing with the sun. The sun is only 10,000 degrees on the surface. Its corona is millions of degrees. It's because it's being scrubbed through the universe like this, and it's just gigantic. And the outer atmosphere out there, which it has an atmosphere just like everything, is scrubbing and causing these ignition sources to, and that's the radiation of the sun. And from every luminous body, the bigger they are, the more luminous they become. Simple as that. Okay, listen to this now. I put in, does a battery change weight when charged or not charged? It says, yes, it does change weight, but listen to this. However, the difference in mass is so tiny, it's practically impossible to measure with standard scales, even with really high-end scales. For example, even a fully charged lithium-ion battery, such as in a car, would have a change in mass on the order of nanograms, which is billionths of a gram, and a gram is pretty tiny. Billions compared to when it's fully discharged. So it really has no weight to speak of. Man, I can tell you something. I worked with scales, and I had test weights that had to be certified by the Weights and Measures. And you had to leave them there for 24 hours to have them become the same weight as, the same temperature as the room, so that when they put them on a scale, they wouldn't weigh differently. That's because electrons have a weight. When they're in a dipole form, when they have the black attached, they have no weight whatsoever, none, zero, when you push the white away from the black. This I know for a fact, because I had to leave my weights there overnight so that it could absorb the dipoles. It wasn't just absorbing white, to warm up. It was absorbing white and black particles. So it warmed up, and it actually gains weight. When things get warmer, they gain weight. And this is a fact. This is not my guess, and I've known this for many, many years. And that is because dipoles are absorbed of heat. They're just heat and warmth and so forth. They're extra electrons. They are not the white part. The white part is electricity, and that's what we created with the Venturi. All right, chat and all the rest of them are clueless about this. I asked, is a hot object heavier than a cold one? He said, yes. If you have absolutely identical objects that have the same weight exactly when they are at the same temperature, then when one object is heated, it will weigh more. Yes, it's accepted more electrons. That's the heat, is electrons. They absorb and they come back out when it gets cold. Simple as that. It's because the gravitational force depends on the stress energy. No, it has nothing to do with any of that. It's that there's more electrons have flooded in to that mass because they're more wanted there. When it's real hot, it's going to weigh more because it's absorbed more electrons. It's simple as that. And they told me that at the weights and measures, although they didn't understand. Because I said to them, here's what actually did happen. I got to tell you the story. It's kind of funny. It was a cold day. It was in Connecticut. And I went up to the weights and measures, and I brought my scale weights, and I said, can you certify these? And he said, yeah, just put them over there. I'll get them. You can pick them up tomorrow. He gave me a time. I said, well, why don't you just do it now? The guy was just, I think he was drinking coffee and reading a paper or something. He wasn't doing anything, let me put it that way. And he said, I can't do it today. I said, why not? Is it a big thing to do it? And he said, no, it takes only a couple of minutes, but I can't do it until they're the same temperature as the room. And I said, well, why would that be? And he says, nobody knows. He said, but, and he had a scale. You want to see the scale he had, because these are for trade, in supermarkets and everything. So when you go in to adjust them, to calibrate them, your weight has to weigh correctly. And, the funny thing is, it still wouldn't weigh correctly if you brought in a cold weight, even though it was weighed at 5 pounds, and you brought it in, you put it in at 5 pounds on a cold, hot platter, it would still be a difference. Anyway, let's get off that. But it is different. And all it is more electrons. Now, what do electrons do inside of a wire? The hotter it gets, the more resistance it gets. Well, hotter means more electrons, because and there's actually going to get more weight in that wire. And the hotter it gets, the more resistance, and the hotter and hotter and hotter it'll get, because there's too many electrons in the wire. Simple as that. And we experienced a problem here in Connecticut with the electronics when they first came out. We brought them in cold to some of the insurance companies and so forth to deliver a whole batch of new machines. They ran perfect in the shop. 70 degrees, they were great. And we brought them out and we put them in the offices, and they were freezing cold. And because the guys had them in their cars overnight, when we put them in the offices, they literally exploded. And I did the research on that. I was the one that actually did the research to find out what happened. And I found out that at a cold temperature, the conductivity, there was almost no resistance to the wires. So the chips were so tiny that they couldn't handle that much current, because there was no resistance. There's a certain resistance built into everything. It says, only so much can come through here, otherwise I'm going to explode. If you put everything you can through here, I'm going to pop. And when the resistance values dropped because the electrons were missing, they just float out of there because they go to where they're accepted easily. So there's no electrons in there. You go into an office and you plug it in, pow! And that was the General Instruments chips. And this goes back in, I think in the 70s it was. And I was tasked with figuring out why these things were not working. I was the field engineering manager for Victor Business Products, Walter Kidder Corporation. And we put in some of the first equipment, and when our guys were putting them in their cold cars, they would explode, literally explode. Now, ChatGPT says that you wouldn't notice in everyday practice the difference in weight when an object is hot or cold. I agree with that. There's only so many electrons it's going to take in, but the weights and measures, they knew that it would be heavier. All right, I think I'm going to pretty much leave it at that. Thank God somebody's finally paying attention to this. And it's been a tragedy that hasn't been paid attention to 10 years ago. So don't forget, the anatomy of the proton is dipole electron flood theory. Everything's dipoles, everything, 100%. And they can talk about gluons all they want, because I agree. It's only these two particles that exist, and they're normally glued together as what we would always thought was an electron. And then back to back, they make photons. And then in a mass, they make molecules and atoms. Protons, neutrons, whatever you want to call them, they get bigger and bigger and bigger. And all of this stuff, the redshift, is completely nonsense, and we're wasting tons and tons and tons of money doing all this stuff, and they won't they look at anything that is outside what they want to see. Very, very distressing what has happened to science. It's just become nothing but a search for funding, as far as I can determine. And I'm telling you, that's my comment, and I will not retract that comment. Because it's nothing I have seen is a search for solutions. It's a search for grandioseness or cash, one or the other. And you have to have both to get one or the other. And revolutionary quark-gluon model, well, like I said, this has been going on way too long. We should really have free energy now. If this electron shower thing works, I don't see why it wouldn't. You saw the white has no mass, has all the energy. We can squirt that out all day long. And when I say squirt it, I mean we can focus it exactly where we want it. Look at this. Where's the real? I call it, and there it is right there. These are all the quarks. You get here. And then to get to there, you put it through your devices. All right, so in other words, you harvest your white and you put it down your batteries. And eventually it's going to hit black, and it will do this. This is the merge. When white merges back with the black, it creates these fields. Those are Higgs fields. Now, CERN and the rest of them have it backwards. They think the Higgs fields are when they fall apart. No, it's just the opposite. The Higgs fields are when they come back together. And they can't tell because they're splattering things all over. See, they think the Higgs fields are when they come back, when they're split apart. And they see them like this. Yes, they are split apart. But when they come back together is really when you get the Higgs fields. These are when they're coming back together. The white's coming through here apart from the black, and here it's starting to join back with the black. And that now it's becoming some kind of a mass. We need to look at it better. Here's the whole thing in one nutshell. Boom, 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 boom. Or your little particles, get out of the way, get out of the way, and they push out of the way. And then all of a sudden it says, woo, there's a Venturi up there. Takes off like a Z-rocket ship and pulls itself right out of its own wave. Magnetic field, just like a jet fighter pulling out of in the sound wave. And here's the explosion with the kickback, and here's the particles coming out, looking into that. We see this coming out. When the white smashes back into the black particles, you get the fields. And these are, I showed you the photons a number of ways. This is something that I can understand it now, but I worked on this for probably almost 10 years to try to figure this out. But now I have it figured out, and I won't tell you unless somebody from mainstream wants to talk about it. Because that, my friends, is something that needs to be discussed. All right, now, again, finally they're taking a look at what is undeniable. And this was really, I'm telling you, I told Don Lincoln I was going to make this loud and clear that he was just not doing his job. And that's just a fact. If you think he's doing his job by telling me that I'm a tinfoil hat guy, when I'm showing all this stuff and doing all this work to try to get something done instead of just searching around for cash, and they're in trouble anyway. I heard Fermilab got some serious problems with a bunch of different things. We'll see. It's worse than I thought. Trouble strife deepen at the particle physics lab. Fermilab doomed without management overhaul. Don Lincoln's got to go, that's for sure. Fermilab plans staff furloughs. Fermilab whistleblower report, and then they have sexual abuse. It's just a playground. Trouble at Fermilab, major shakeup coming. Trouble to close Fermilab. Unbelievable. I've been blowing a whistle on them for many, many years, and now they have finally caught up with it. And I'm, as far as the technical side of things, I'm pointing my finger at Don Lincoln. I showed you what happened. I tried to contact him, and he assaulted me. So they should have been doomed many, many years ago. Billions and billions and billions of our tax dollars, where we could use these in these flood areas, and we're having fire problems and everything else. It's just being doled out. Doomed. Okay, I'm leaving it at this. This just came in 2 minutes ago. Astronomers discover complex carbon molecules in interstellar space. Well, I'm not going to go anywhere. Extraordinary trinary black hole system, first of its kind ever found. That's all good. That's fine. Look at this stuff. But don't make these claims that light never slows down, and that you can judge how far things are, and that everything's being pulled away at a certain speed because of the speed of light and that redshift, and that's where the galaxies are billions of years, this and that. I showed you the thing. Well, you can see. There's zero possibility this light not going to slow down in that. 100% certainty. 100% certainty. Not even close to coming through this stuff. And then there's all kind of dust particles, and every light particle is a subatomic particle winking in and out of existence, exactly as Don Lincoln says. All right? Empty space experiences similar activity as root beer head. Subatomic particles winking in and out of existence. What does winking in and out of existence means? It means when other particles bang into them, they slow down. That's as they wink. It's unbelievable, unbelievable. I at one time thought it was just, they just didn't really understand. Oh, look, they'll come around. No, it's not that at all. And there's zero person on the face of this planet that's that incompetent that can't understand what is going on here. So I don't know what the motivation was at CERN or Fermilab or any other place. I went to all of them, 100%. Every one of them I sent to. JPL, Jefferson Lab, Lawrence Livermore, Caltech, you name it, 100%. I figured somebody somewhere would respond, but no. Nope. Doesn't work that way in science. So there should be somebody out there who's got some money would like to invest in this. That, I don't want any money. I'm perfectly happy the way I am. I don't want anything. I just like to see some help to try to save the Earth a little bit, but I don't think that's the goal anymore. I hate to be such a downer, but boy, I tell you, after 15 years of this, you realize that it's just designed against scientific improvement in life. And I think it's mostly here, I got to be honest with you, but I'm seeing it mostly here in the United States. I see other countries, I don't know what their abilities are, but they're doing some pretty impressive stuff. And I think we need a change. just like a Fermi lab. That baby's got to go. And Arizona State University, same thing there. They're studying Bennu. Of course, so far we got $1.16 billion into Bennu, which is an asteroid that is a heart in space. It came back with sarcomeres and membranes, which are the phosphates layering the sarcomeres. And I've been trying to contact people for over a year about that. Not a single word will be spoken. So that's we're up against. Everybody needs to get by and get funding. I agree with that. But to get something for our funding would be a lot better. And that's all I'm asking, is for this to be examined. And like even Bennu, I mean, this is a zero question, 100% certainty that it's a heart. And they know that. They know that they have it here in their hands. They went out and took it and brought it back. And before they even came back with it, I said, that's a heart, and you're going to find that there's going to be all the chemistry of the heart there. I was blown away when I saw that the actual heart muscle sarcomeres were there. In addition to the phosphate layers, they said, wow, phosphate surprise, we never expected this. 2 layers of phosphates with muscle sarcomeres, actual muscle sarcomeres in between. Can't be missed. There's no way possible. And they won't respond. And they have spent $1.16 billion, and they think within the next few years they may be able to figure something out. All right, time to make some changes, my friends. And apparently they're the ones tasked. Whoever gave them the money, NASA, I guess, gave them the money to examine all this stuff. And I don't see they're doing their job. I'd like to be part of this. I've shown them what it is. You see this? They went out to Bennu. This is Bennu. This is asteroid Bennu. They landed a lander on there, picked up something, came back. Well, I'm going to tell you right now, that is a heart. This is a heart. They break right at that seam right there. And the plumbing comes right off of the top, and you're at this point where you can see down into the valves. That's this. This is Psyche, another heart. It's another heart in space. Exactly identical. Only this one's got next to too close to the heat of some sun or something, and it cooked it enough to where it smelted the surface. And I'm sure inside it's not 100% metal. And this one here has just been like ionized, but not smelted. So it didn't get close enough to be heated so much. It's got to get at least 2,700 degrees right in that area to start turning into metal. These are the valves, though. And all these colors are the colors of blood. Shown this many times. It's been a year now. I've been showing this over and over, trying to contact somebody. They claim, we're giving everybody samples. We're giving samples to everybody. No, not to me. They won't talk to me. And that's the heart. And here, what is a heart made of? Well, here's what they came back with. There's a layer of membrane here. There's a layer of membrane up here. And in between is this, which is the sarcomeres, which is the muscle sarcomeres. And this white stuff on the top and below is phosphates, which is from the phospholipid membranes. Look at this carefully, because that, my friends, is from a heart, which this is as well. This is a heart attack victim, ripped here. These are the sarcomeres. They're supposed to look like that, and they're supposed to pinch. Boom, 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 boom. That's how your heart works. There's a layer here, and a layer here, and right? There's layers on these blocks. They're little blocks, and they're all sort of working, and they're pinching and pulling and all that. And that's what they picked up off of Bennu, right there. That can't be missed. It's absolutely undeniable. Plus, the chemistry is exactly the same. Exactly the same. And to deny this and say we need another few years to, because it's already been a year. And before they even came back with it, I said, when you come back with that, I want to know what it is. And I sent them exactly the chemistry, because I had a big long list of details about the chemistry that I would expect to find, which is the same chemistry that's in blood. Because heart is just nothing but blood. A heart is virtually 100% blood. I mean, even the muscle of the heart, that's just saturated with blood. This is the only part that doesn't have a lot of blood. And see, that's this part right here. See? That's the tendon. Tendon doesn't have much blood. That's why it's white. The rest is just saturated with blood because it's a muscle. And boy, they use a lot of blood. You see it right here? That's all muscle. This is all muscle around here. And these are the valves where the blood goes in. And there's tubes sticking out of here. You see that? That's a tube. And so is this one down here. That's a tube. These are not impact craters. All right, so again, they treat me like an idiot because I expose these kind of things that nobody will talk about, and I understand them. I discovered the mud fossils, and no question whatsoever. They're DNA tested. I got them CAT scan. I got specimens coming out of my ears. I got chunks of meat. I found new body parts. Giants is a hair follicle. That's the erector pili muscle. That's the sebaceous gland. There's the hair shaft. Flat-sided means it's a curly-haired person. There's the vein and artery at the bottom, 2 inches wide. It's from a giant, obviously. I don't think there's anything now that would fit that script. Boneheads, bones. I got bones, I got fingers, I got all kinds of things. From giants, from normal-sized people, from little tiny things. I got different types of, all kinds of things that, again, will not be examined because they do not fit the narrative that the leaders in these areas want to promote, because it supports their wrong ideas. And now to not even investigate them, not even look, not even talk, not even discuss, not interact, that exceeds incompetence. It goes much more past that. Plus, these are public employees. These are people we have given our complete faith and trust in. And I say that would be, to do what was done to me from Fermilab would be a breach of public trust. To say, oh no, Roger, that's not, just get out of here because you're a tinfoil hat guy. And I know it's because of my mud fossil stuff, I'm sure. Because to see this, how could you possibly miss this? It's impossible. Don Lincoln is arrogant and obnoxious to boot. So, and I told him, I said, "This is, buddy, I'm not going to back down, buddy. This is going to happen, and you should have done your job." And I kept asking him, "Please, Don, please, please, no." And not nice about the no's at all. And instead of saying, well, trying to explain why I was wrong, it was I was a tinfoil hat guy and a disgrace to science. I was an embarrassment, actually, was his words. I was an embarrassment. Well, I think you're an embarrassment, Don. And Fermilab should be just closed right up as far as I'm concerned. It's just a total boondoggle, waste of money. And they're digging gigantic holes looking for some dune experiment with deep underground neutrino experiment. It's absolute boondoggle. Billions and billions and billions and billions, I don't know how many billions, wasted for the last 10 years, which we could have got something for our money, maybe. All right, so I'm sorry. It's time to change this scenario and get out of this domination and peer-reviewed nonsense of things that just aren't right. They're just not right. Light accelerates, light slows down, light's a particle. It actually contains the dark matter they've been looking for. Everything there is, in the core of it, is dark matter. The only thing we see is the glowy parts on the outside. If you were to get to the inside, there'd be a black core. But you never get to the inside unless you do what we did and put the black particle on top of the white. You see it? You'd never see that black. You don't see that. The only time you see it is because it's obstructing the white. Dark matter and dark energy and this is dark matter. It does not radiate, it does not absorb, and it does not emit. The only way you can see it is to put it on top of the white. You see it? That's the only way you can see it. Some of it's sort of obstructing a little bit, and then out here it's coming back. And the blacks, they don't care about being right next to each other. The white will not do that. The white says, you get away from me as far away as you can get away. They hate each other because their fields interact. The black just pushes the white. All right? And it wants to be attached to the white. They are intimate partners. And this, if they want to measure attoseconds, that's about, I don't know, 7 attoseconds. I don't know. It's right here in front of their faces. All they have is little doodles and simulations and ideas. It just boggles my mind how intransigent these people are. All right, if you're interested, just keep your eye on my channel, because I'm just going to keep going over and over this until they start to look at this for what it can be done. They're showing simulations of this and that. I showed the actual experiments, and this is what I'm saying most likely the atom looks like. Now, I looked at this too, which would be a different configuration where you had a black and then a tightly held and then another layer of black and then tightly held green, but I don't think so. I think the black completely congeals to the center in this model. There's 2 possible models. This is my favorite. But this is the 2 particles. They make up everything there is. That's it. That's it. That's all that exists. All right. Now, this is going to be the differences from the standard model. Not much. Not a whole lot. And this was done on Rod Warren's light experiments, are the things I've been showing. Now, he has disassociated from this now, but I hope he gets his credit for what he did, because when I saw the experiments he was doing, he didn't realize what he was doing. He was trying to get the double slit experiment, but he was using a Venturi, and I said, how did you do, because I saw the results, I said, how did you do that? And he explained to me that he used literally nails, round nails, and he had 3 nails, so he had a double slit, and he shined light through it when it came out the other side, and he used a Samsung phone, and I have all the stuff right here. I get the same stuff, and I just was not, I didn't have the time to do it, and I was not good at doing it, but I know it's been done because he did it. I got more pictures than you can imagine of the light research. I have hundreds and hundreds of pictures of these photons splitting, dividing, red, green, blue, how the light comes in. I have so much, it's just unbelievable. But this, to me, is no question, this is what they're talking about at Fermilab and CERN and everywhere else, and they're the smallest particles that exist because they are light, which is supposedly an elementary particle. They say they have no mass. They absolutely 100% have mass. And they work on a really interesting principle of magnetism and mass, which causes you gravity, dark matter, magnetism, mass, heat, energy, all of that is locked in that little bugger right there.